So for the last 2 times that we have together this year, we're going to talk about area and perimeter a little bit. So today we're going to focus on 2 shapes that we spent a ton of time on this year. We're going to talk about triangles and parallelograms. And I'll probably throw a square in there as well because square is a type of parallelogram. Okay, so the area of a square is the square of the length of its side. So you're typically used to thinking about length times width, but with the square, your length and your width is the exact same. So another way you can do it is s squared, and s is just whatever your side length is. I'm going to kind of go through all of these, and then we'll do all the examples. Postulate 25, area congruence postulate. This one's pretty much common sense. It says if 2 polygons are congruent, remember congruent means exact same size, then they have the same area. Well, that makes sense. If the shape is the exact same size, its area is going to be exactly the same. The area of a region is the sum of the areas of its non-overlapping parts. So if you're trying to deal with a shape that might be a couple different shapes put together, you just find the area of all the non-overlapping parts and add it up. Area of a rectangle, again, rectangle is a type of parallelogram, is the product of its base and height. Again, you're used to thinking length and width. The reason we put it in terms of base and height this time is you'll see when we get to parallelograms. Let me move down just a little bit. So the base is the same thing as your length, and the height is the same thing as your width, or vice versa. It really doesn't matter which is which. When we talk about parallelograms, we want to be able to identify what the bases are. So either pair of parallel sides can be used as the bases of a parallelogram. And then the height is whatever the perpendicular distance between the bases is. So in this diagram, to find the height, the way it's labeled, this would be the height. Okay? But we could also have it oriented differently. We could have the longer parts on the sides. Pretend I can draw. Okay, and then the height would be this distance. Okay, so it can be oriented a couple different ways, and you'll see that when we get to the examples. To find the area of a parallelogram, it's the product of the base and the height, just like a rectangle is. You might think, well, a rectangle has 4 right angles, so I get it. It's just base times height. Why does that work for a parallelogram? Well, if you think about a parallelogram, you actually have a little triangle here. If I take that little triangle and put it on this side, then really you have, if I outline that new shape, really you do have a rectangle. So that's why the area of a parallelogram can be found the exact same way as the area of a rectangle. For a triangle, and again, hopefully this one is a little bit of a review for you, the area of a triangle is 1/2 the product of a base and its corresponding height. So 1/2 base times height. And again, that works because if you take that triangle and flip it over and put it back on, right, it turns out to be a parallelogram, which is base times height. So a triangle is just half of that. So the area of a parallelogram is exactly the same as the area of a rectangle, base times height. The area of a triangle is half of the area of a parallelogram or a rectangle. So these are all the formulas we're going to talk about. They are all on that formula sheet if you want that to help you. Now let's get into some examples so you can kind of see these worked out. All right, so example 1 here, we have parallelogram PQRS. So parallelogram, remember your area is your base times your height. So your height is dependent upon what bases you are choosing. So in this diagram, you have a few options. You could say, okay, I know these are parallel, so my base is 6. Okay, so we'll have area equals 6 times. if we're using those bases, then the height has to be the perpendicular distance between those that we outlined. So the height, the perpendicular distance between those bases that are 6 is 8. Okay, so knowing that, we would say our area is 48 units squared. Now you have another choice though. Looking at the shape, you could say, okay, I'm going to say that these two are parallel, which they are because it's a parallelogram, and I'm going to use those as my bases. So then the base would be 12. Well, if you're using those as the bases, that's totally fine. Remember, your height has to be the perpendicular distance between them, which in this case would be 4. All right, no big deal. 12 times 4 is still 48 units squared. So again, it does not matter which way your eye looks at a shape. You should still get the same answer. Down here with more examples, we have a triangle. So a triangle, remember, is 1/2 base times height. If you want to pause the video and try these on your own and then come back, feel free to do that. The way this triangle is oriented, my base is 21 and my height is 8. Okay, so my base would be this part here. That's where this is coming from. And my height then is a perpendicular distance, would be 8. The only perpendicular distance you're given here is 8. So really our only option in this triangle would be to have the base of 21 and the height of 8. So if we go ahead and multiply all that out, half of 8 is 4. 4 times 21 is 84 units squared. Okay, next up we have a parallelogram. We know that because opposite sides are marked parallel. So for a parallelogram, separate the space here, it's just base times height. Okay, so again, with what we're given here, my base would have to be 30 and my height would have to be 17 because, again, the height has to be that perpendicular distance. So that's 17 in this case. And then the base would be the 30 in this case. We don't have enough information to use the 20 as the base because I don't know the perpendicular distance between the sides that are 20. Okay, so then if we multiply that up, we get our area, which is 510 units squared. And then the last one, again, is a triangle. So triangle is 1/2 base times height. So again, we're looking for that right angle, which in this case is right here, which would tell me that I have a base and a height here. But my base in this situation is unknown. So what we would do, since it's a right triangle, do Pythagorean theorem, and you may remember now that 5, 12, 13 is a triangle that we've mentioned numerous times. So this base will be 12. Again, if you're not sure where I got that 12, you would just do 5 squared plus x squared equals 13 squared and go through and solve that. So you'd have 25 plus x squared equals 169. So you get x squared equals 144. So x is 12. That's the background if you forget how to do that. Okay, so then half of 12 is 6, and 6 times 5 is 30, so this area would be 30 units squared. So that is how you do area of parallelograms and triangles. Let me know if you need any help with anything.